Hey, morning everyone. My name is Yuri. Let's get started. Let me know if you can see me, because I changed my setup just a bit. The mic and the video should be a bit different, so let me know if it's okay for you. And let's get started. And meanwhile, I'm gonna try to get a bite. Well, can anybody hear me? Am I streaming alone finally? I was going to look on a sketch. Sup, bro? How's the weather in Dublin? We can hear you, but can you see me? That's the question. Alrighty. So I've done some... well, it should have been. I was going to cook some desserts in the April, but I think this date of the stream just barely missed the 1st of April, so I didn't do that. Yeah, so recently I've done some pretty beautiful GIFs. Baghdad, oh, hello to Baghdad. Some beautiful GIFs. I also support my friends from Belarus. If anybody from Belarus, Belarus. And then these hands, and then this particle thing, and also some different ones. But a couple of persons asked me about this one. This is it, and I think this is actually a nice thing to do because it's quite simple, contrary to what I was doing lately. This one is quite easy to do and might be a beginner friendly and might be something that you could start with the shaders and GLSL. Oh, first world problems. Painting a fence and then rain. I don't even have a fence. Should I have one? Okay, so we'll do this one. Shouldn't be hard, but of course you never know. Never know. Something always breaks in the process. How do I call it? S. I'm gonna call it just S because it is sphere, and that's why it's gonna be S. All right. So I'm gonna start with creating the canvas sketch template for the threejs. Let's just do that. Where's my terminal? I'm gonna go straight to the S folder and then do this thingy. And we'll create everything and then install all the dependencies and even run it for me. This is perfect. Okay, so now we have a sphere. Yay. Already good. So let's open it up. A sphere right here. We have a 3 module already here installed. And then let's do the duration right away, like 3 seconds. Let's say FPS is 25. And then I kind of want to move this sphere just to check that everything is working and everything is in place. Equals playhead multiplied by 2 pies. Yeah, just reading my thoughts, you know. My face smaller. Ouch! Ouch! Well, thank you for that. I bet you'd like to see my stream. What I think about React 3 Fiber, well, I did last stream with React 3 Fiber and I like it a lot. It's not that common to use React in webgl community, so usually I do just some module without React. But if the project includes React, I think it's a must to use React 3 Fiber. It's a lot easier and a lot more readable. Yeah, season 3, okay. I think my face is small enough right now, so we can continue. So I wanted to rotate this mesh. So you know, the only thing I did so far is just run one command in my terminal to start the sketch. This one. So like anyone can do that, and straight away you can get a threejs setup scene with the sphere geometry and all this stuff like that. So then of course you need to know some basic API for the canvas sketch, because they have the playhead and the time running from 0 to infinity, and then playhead runs from 0 to 1 the whole time, all the time 0 to 1. And then yeah, it's gotta be some axis rotation. So yeah, now we have the perfect loop animation, and it should be enough to post this GIF already. So let's continue. First of all, I'd like to use shader material. I don't really like this mesh basic material with a wireframe. You can use mesh normal material, which is kind of better, but still ugly as hell. You use a green screen on software. Yeah, I use a green screen. I also like this sphere. I'm not sure I'd like to spoil it with some animations. Okay. Material. I was talking about moving to the shader material, and because I don't really, actually I don't remember anything from the threejs. I lie, but still I hate typing it all again. So I'm gonna just copy paste the material and then include the shaders. So let's get the material. Let's call it const, because I want to look younger than I am and use const. and then what? And then I need the vertex and fragment shaders as well. So I'm gonna copy paste those includes, just like that. Yay. And then we need the two shader folders. I mean, one shader folder with two shaders. And let's just do that, because we can do anything, because it's Sunday morning. You can do anything. Yeah. What I was going to do. Yeah, I was copy paste into the mockup, and then the shader folder is in place, and then so it's gotta be working right now. So I'm already using this material variable. So hey, hi everyone, morning to you. And then I need to see, I probably should see the UVs, but I don't see them because why different type? Oh yeah, because I have a typo in my shaders, which I haven't fixed like since 2 or 3 streams already. I think I had it. So it's 3-dimensional, and then somewhere it's gotta be 4-dimensional. Yeah, right here. So now we have the UVs visualized for our sphere, and I think it reminds me of a pitch. So I gotta take a bite. So we have 2 shaders, which is not that cool. We can make a red sphere, easy peasy, lemon squeezy, into north face. There gotta be some math function probably. In Wolfram they have all those kind of functions. Well, they paint the Simpsons with just math curve and all stuff like that. All right, shaders, fragment and the vertex shader. What I was going to do. Well, first of all, I don't like this sphere look because it kind of looks like like red, so it's not really interesting. First of all, I want to make it flat shaded. Like there's this difference. Mesh normal material. Let's get back to the mesh normal material. Where's this material? This is not the right file. Come on. Get your shit together. So this is mesh normal material. Then you can do flat shading, true, if I remember it right. And then let's try to use material 1. So yeah, you see how the look of the sphere, okay, I should get rid of this rotation, how the look of the sphere changed, because well, right now it's not interpolating the normals on each of the faces. Now you see that the shape is not actually a perfect sphere, even though we see it as a perfect sphere from normal point of view, from normal vector point of view. But it's not really a perfect sphere, it's just a number of triangles with the normals, which are then being interpolated. So this is the first look, the first trick into this animation. So we've gotta be using the flat shading true. Well, not really, but in theory. And then let's switch back to the material. And by the way, we still have normals right here. We should have them. Like, we could do this varying v normal, and then do this normal equals normal. And then we need to use this varying here as well. And then I could just visualize normal in my shader material. Well, they are different space normal, but still normal. If I do it like this, it's gonna be the same. All right. I think I could even change the camera position to get the same. Yeah, so going to be looking from behind or the front. I don't know what's front or behind in this system of coordinates, but still just looking from the other direction at the 0, 0, 0 point. Next I'd like to use some noise function. So let's use the noise function. I already copy pasted some, so I wouldn't spend time looking for it in Google. And it's just a generic one. If you Google JLSL noise, you'll find this one. It's nothing. Come on. Nothing really special about this one. And then I'd like to use this one inside my Vertex shader. So this noised thing actually returns vect 4, and this is because it returns derivatives of the function. I don't really need derivatives at this point, but I kind of happen to like the output of this noised function and the simplicity of it, so that's why I'd like to use this one. Oh, I think it's using the #1 function, and oh fuck. Okay, let's just look for #JLSL. #1. I think it's even might be the same function. I'll just copy paste this. Should be fine now. Okay, so let's try to run it now. So I have this noised function which takes a three-dimensional vector which happen to be a position. I mean the position on the system of coordinates and so forth. So let's use it as this calls noised positions. Now we have some noise parameter. Let's even try to visualize it. So I'm going to do v noise equals noise, and then do the and then I could just as easy as that visualize it in my shader, hopefully. But no, because why dimension mismatch 108? Oh yeah, because my noised function actually returns 4-dimensional vector, and yeah. I wish it would work the same in JavaScript. Oh wait, we have a TypeScript for that. So now we have some kind of noise which is calculated in the Vertex shader, and because it's so big, I could multiply it by 4, let's say, so I have more spots. Yeah, something like that. It's not that cool because it's been calculated on the Vertex shader, and you can easily see the interpolation part, like because it's been calculated for each vertex of the geometry. Right. But why I need that? I need that because I wanted to, okay, let's get back to the normal view. I needed that to distort the sphere. So what I would do like 3 new position equals what? Equals noise multiplied by normal and equals position plus noise. So I'm going to be adding to each of the position of the sphere. I'm going to be distorting it in normal direction with a noise function. And because noise is probably between -1 and 1, and the whole sphere is 0, 1, I'm going to multiply it by something small. And then I need to use, oh wait a minute, I think this code is right behind my back. I'm going to use it like this. So now we have a distortion. It's not being moved yet because I'm not using anything, so I'm gonna use the float playhead thing, and then I need to set it right in my shader. So I'm gonna do mesh uniform playhead equals playhead, and then it's uniforms, for fuck's sake. At GPT-3 now, it could have guessed what I was trying to type anyway. So the playhead is in place, and now we have something. No, not read playhead of undefined. Yeah, I think we have material, so we could just do. Oh, it should have been material here. But I think it's even better to just have material because I anyway have this material global. It's right here, it's perfect. I have playhead and I was adding it just to make a dynamic distortion of my what? My object, which is right here in a folder called S. And what I wanted to do, again, I keep losing my thoughts. Yeah, I was going to add the time here. So instead of using this like that, I'm gonna do, let's make a shorthand. I hate typing. It's gonna be px, py, pz, and then let's say I want to add playhead here and multiply this whole thing by 4. Yes, now we have a kind of living creature. It does live, but well, the first thing, if you're familiar with all this 3D stuff, you notice is it doesn't really look good. I think that's the right word, because you don't really see the distortion with the normals, and those colors are actually normals, and when we distort the surface we should see the distortion of the normals. We don't because we're just using the static attribute called normal, not really using the changed normal, because we're changing normals while we're changing the vertices. So for this to work, we wouldn't need to do this like this. So instead of kind of want to use vPosition equals position, but and then I think this view, let's call it view, and then in fact for the view equals this. This is the position of the mesh in my system coordinates. I think I could have used just new position here, but anyway, I might want to use this one later on. So I calculate new position right here, then I use it in here, and then for the rendering in the last line. But so I need this position updated, so I want to use this XYZ. So now I should have the position. I like your attitude. Yeah. So it looks better than before, at least it's not the red sphere anymore. Yeah, I think this is something cultural. Something from the childhood might be. when you're not good enough. You're always not good enough. All right. So yeah, I think it's already looks cool because you can show it to some non-tech savvy people, and then well, it's cool. It's 3D programming, but we're gonna make it look much better now. So I was going to transfer the V position into the fragment shader, and now I should have it. We can visualize it. Let's see what this V position is about. Yeah, it's some V position on the screen. And then what I could do, I could calculate the normals depending on this V position. So there's this thing called derivative functions in GLSL, which states that you can actually calculate normals right in the fragment shader, not in the vertex shader. So to do that, you do something like sort of where set. It's gotta be a common way. It's usually easy to Google that, even though I have it somewhere in my snippets. I kind of wanted to see it in the wild. So I think this is the way. Let's try it. So those are derivative functions, and for those to work you actually need this part, derivatives enabled. And then instead of this I'm gonna use position, and then the normal, like let's call it n because normal might be already in there. And let's visualize this normal now. And behold, now we have a beautiful shape, even more beautiful than it was before, but we would push it even further. So it's cool and all, but not cool enough for me. Ah, fuck. I did it again. No, it's cool. It's cool, right? That's already cool. Okay. I do that subconsciously. Okay, so now we have this beautiful shape. We can play a bit with the noise function now. So now let's say you want to do some simple math with the noise function. We would go to the vertex shader, and instead of just calculating this noise, let's say I want to do noise multiplied by noise. So noise to the power of 4. It's gonna look a bit different. Well, that's just power of 3 maybe. So it's starting to look different. It's like easing function. You could always do the ease in out function, which looks usually like that. Like the simplest one that I can remember is this one. It's the scale is a bit more dramatic, so like you see the difference. More flat, but with is in out function, and that's because is in out curve, it looks like that. So kind of when we do this curve, we concentrate more distortion in the bottom and in the upper part of the curve, and this one goes really fast, so we have more dramatic distortion of the shape instead of linear, where it's like the probability of distortion is the same. I don't know if I'm using the right word for this one. I don't even know how to describe this in Russian, but I hope you understand it. Using this curve we get just more dramatic valleys and hills in our shape. Alrighty, getting there. So we could multiply this one. Well, another thing you might notice is that it's not actually looping now, because the noise is going from 0 to 1 and then scales. So to make it loop, I'm gonna use a small trick. And where do I use it? I'll use it right here. So I'm gonna use the sine function double pi, because this is a period of time, and I think we gotta be having pi somewhere here. Yeah, we have a pi. And then yeah, it's double pi multiplied by the playhead. And then I'll do the same for another axis, but with a cosine. So it's like drawing a circle. So in the end, when the playhead is going to be 1, we're going to be back at the original position. And this should just make it a perfect loop. It's a little too fast, so I should probably multiply it. And lo and behold, this is a perfect loop now with the noise function. Easy as that. I think I just spilled some water on my iPhone, but I don't care because it's an old iPhone already. All right, now I have the perfect loop, and let's see this GIF. Though, like, the tiny details actually make a lot here, and you could see that we have those points and edges, and let's try to do those points and edges. And another thing to do here, if you look closer into the triangles, not really, it's like a square triangles, right? It's like a right triangles all over the place, which I don't like because I like equilateral triangles. And then let's try to use them. And to use them actually quite easy in threejs, because instead of sphere geometry, I could use this, and I think it takes just 2 variables like this. No, it's not a construct. So I actually bugger geometry. All right, so now it looks much more beautiful. I think it's 3. Yeah, it's good enough. So now I have better kind of looking triangles. Well, in general, I think I like more icosahedron buffer geometry than the sphere buffer geometry. It's more preferable. Right. So let's try to make the edges first. Let's try to make edges. So to make edges, I could actually do like another geometry. Const edge gel equals new 3 edge geometry. This geometry. Did I mess up? Okay. Gotta Google that stuff. Edges geometry. Again, with GPT-3 integrated, should have fixed this mistake. And then, well, I could actually try to use this geometry right away and to see something. It doesn't look good because we're using the mesh, and yeah, so let's not do it this way, because it randomly connects all those edges geometry parts into the triangles, and we can see some contemporary art thing, which is actually a bug. So we have the edge gear, and then I'll create another mesh, like mesh lines. I'll add it right away, and then it's gonna be edge gear, right? It was edge gear, yeah. Edge gear, and then instead of mesh, I think I want to create just line segments. I think it's called line segments. So I needed to start typing in Google to remember that. Line segments. Yeah, now we could see this one. It's actually using the same material, but it's not being distorted for some reason, which I'm gonna fix pretty soon, hopefully. So I have the mesh lines, and I think I want to use another material for this one because I don't want it the same color. I want it to be white. So let's use this one. So maybe I should use the same vertex shader, and then the fragment 1 and fragment line 1. Let's duplicate. So we have 2 fragment shaders, 1 vertex shader now. We have 2 materials. Material, let's call it 1. I don't need this mesh normal anymore. So we have material 1. Fragment, I call it fragment line. Yeah, so they're white now, but why don't they distort? Well, this is actually looking cool already, but I wonder why are not my lines being distorted, because I'm using the material and it's definitely using the shader because I can change the color. Yeah, now it's some other color like that, like a yellow. But why aren't they distorted? Is the vertex okay? Well, right now it's actually obvious why they're not distorted, but if I change the material, they shouldn't be, they probably wouldn't be distorted anyway. And why is that? I wonder. And I wonder why. Okay, so we are still using new position and it kind of ignores that. So I'm gonna multiply it by 0.1. Something weird is happening. Oh yeah, because we're using the same vertex shader and it's but why? Maybe you have an idea in the chat? I love you, Vaxu. Ooh, this is an unexpected problem. Everything prior to this moment was expected behavior. And now why are those lines are not working for me? You know, I did this GIF actually. And I did it the same way I'm doing it right now. And why the hell the positions are not being changed? Maybe... No, this shouldn't be the reason. So it's line segments. And we're using the geometry, so everything is in place. We're adding to the scene using material 1, which is also shader material, and the shader even works. But why the vertex shader doesn't work? Some basic thing I'm missing right now. Why the hell it's not being distorted? Should have been. Still no ideas. Space playhead to new material. Yeah, I did that. I actually did that. I did that. Material 1 also using playhead now. Even if I didn't, it should have been distorted just a little by the vertex shader is actually working. So when I multiply something with a new position, it actually distorts the thing. That's weird. So that might happen because normals are 0. Should that be the reason? Well, we are quite lucky because we have a sphere instead of normal. We could use just this. That's probably the reason, because this is the edge geometry, this is all lines, and they just don't have normals because it doesn't make sense to have a normal for the line. Well, it does in our situation, but usually it's not. So I think we could just use normalized position. Yeah, that was it. Oh god, I'm so clever. No, not really. Okay, we fixed that. So now I have it in place, and I think for the how do we go about this? Because you see sometimes lines are being hidden by the shape. To fix that, I might just introduce a little bit of the scale to this mesh lines part. How's the API? I don't even remember it. Okay, I need to remove this 0.1 thing. Yeah, it's perfect now. So I just scaled it a bit so it stays over the shape. Already have this beautiful thing to see. I think yellow actually looks pretty cool on this shape. Even better than the white, to be honest. But if you wouldn't be using the sphere, you'll be in a small trouble. You need to calculate normals yourself for each of the points of the dash material, line segment material. Yay. So now it looks even cooler than that. Almost there. So now I need to use the points. Kind of want to use the points. I already have this vertex particle material right here. So let's try to use points in each of the vertices of this shape, this icosahedron buffer geometry. I can actually look at the camera sometimes. I wonder if it makes any change. I can type at the same time. But thank you guys for your support. I'm just getting started now. So I need to use mesh points. I'll use another material. Although I probably could use the same one. Let's start to use the same one, and I'm just gonna change the last bit. The last bit of it to this vertex shader. Will it work the same? No, not really. I'll use another material for this one. I think you might do this with uniforms, something like that, but who cares? Two. Mesh material 2. Yeah, right here. So I have the second material, fragment line, and then I could use vertex particles. Vertex particle, and then the fragment, I'm going to use the same white fragment because I need white particles. Let's reuse the shaders. So it's going to be fragment line and then vertex particles. This is material 2 now. And we have vertex particles, and I think they're too big. What's the error? Vertex particles is not defined because particle. What else? Mesh points is not defined. Yeah. Mesh points. Let's create the mesh points. How do I hide this part? Yeah, like this. Mesh points. So we'll do mesh points. It's going to be 3 points. I'm going to reuse the geometry, the original one. I'm going to use material 2 for that one. Well, that's it. Mesh points is not defined. Ah, yeah. Camel case. So now we have all those points. They're not being distorted, but at least we can see them. So it's already quite cool. To distort them, I would actually need to copy paste, either copy paste or, well, let's try to do something stupid and just do the default shader for those particles. I'm gonna try to reuse anyway. I'm gonna try to do a stupid thing. So the only thing that is different from the particle shader that we need to calculate this particle size here. Let's just try to calculate it in the same shader and maybe it just work. It doesn't. For whatever reason, it doesn't. Well, at least I need to use a new position here. So I'm trying to combine just to use one vertex shader because otherwise I would need to copy paste this noise calculation, and I hate copy pasting. Well, at this this situation, I hate copy pasting. So we have this new position. Why I don't see the particles? What could be the reason for that? Do you know? Okay, fuck that. Fuck reusing shaders. I'm gonna just create another shader. It's not that hard to copy paste anyway, right? Who said that? So I'm gonna bring back the particle material. We see the particles, and then I need to copy paste this part. Copy pasting. I feel so guilty now. I'm sorry, shaders. And then I'll just copy paste this whole thing, calculating position, all the stuff into the particle shader. Do we have an error in GLSL? Yeah, probably. Normal undeclared identifier. Okay. Can do that. Can declare anything. So maybe that was problem all along. No. So I have those shaders and what else? And those points are not moving yet because I'm not using the newly calculated position, which I calculated right here. Could they be just in, yeah, the particle, maybe they worked this whole time, I just wasn't able to see those particles. Yeah, let's try this again. Let's just try this again. I'm gonna copy paste. Yeah, it actually works, so we don't need to copy paste all those shaders. So we could use the default shader. We're using the default shader right now. And this is cool because we only have the noise declaration in one single point of our calculations. And I kind of want to scale this mesh the same way. It doesn't work like that with points, probably. And scale them like 2. Oh, it's actually cool. Not what I expected really, but pretty cool. I think this is the way. Like right now all the points stick to the... I think this particular parameter depends on the size of the point, so maybe like this should be already cool. Yeah, we see the points now and they are sticking to their edges. It's perfect, they're not being hiding, not hiding behind the surface. So it's already pretty cool. Get in there. What else? Maybe you could make them a bit bigger. I think I'd like to see my points a bigger size. Yeah, like that. Still works alright, not being hidden by anything. Already cool thing, right? And then I think the last touch that we need to do, I'm gonna add the sphere. Finally a sphere, not an icosahedron. I can actually use an icosahedron again. I don't need to use another geometry. I'm going to be reusing everything. Just used one single geometry for all the parts now, remember. So I'm going to add another mesh. Another mesh. Right here, like mesh sphere. I'm going to use the same geometry. This time it's going to be mesh normal material. Not like that, not here. Yeah, it's already kind of cool. But for me, it looked even cooler with this particular matcap. So I'm gonna copy paste it right in the sketch folder. It's 2PNG. And then, well, instead of mesh normal material, let's format it a bit. I'm gonna use mesh texture loader. It didn't work out good because 2PNG is not found. Why? Beg your pardon. Maybe just like that. Where the hell are you looking for the 2PNG file? Come on. Maybe just like that. Well, sometimes at this kind of situations I do this. Oh yay, you found 2PNG. Haha. I'm clever than computers. I'm a lot clever than that. Okay. Well, can you guess which one of those was found? Well, actually, it's pretty easy to guess. But anyway, I think what makes it even better and what the last thing that is missing is something like that. Yeah. I think it's too much. Yeah. Now this is cool. Now this is cool. Well, it just finished touch for this one, just so it looks the same as the GIF. It's gonna be equals 0.1. What's it gonna be? To loop perfectly, I need double pi again. Yeah, something like that. It's just a random rotation. Don't think that I just remember all those numbers. It's just a random sign. And here you go. There's a perfect loop GIF, which looks beautiful. We didn't even use a single texture. Well, we actually used one single texture for this material, so it gets this kind of nice look. But still, so now we could play a bit with this one because we have one vertex shader, and we actually did the whole animation under 1 hour, and it looks pretty nice. I can take a bite. So we can enjoy this thing animated. Now we can do the following. Don't need this, don't need this. Make it like this. So I actually had some some amplitude here hard-coded like this one. So let's try to change this. And we can come up with all sort of cool things, and instead of noise being like that, I can again raise it to the power. Now it's getting crazy. It's a disco party, right? What else? What else? Well, maybe just a little small. It's too much. It's like shooting vertices in some direction now. We could also try to change this parameter, like make it 10. And it's a whole other story right now. I'll make it 1. It's quite weird, but kind of fun, maybe? No? Yeah, you can see that just changing the physics and the easing of the noise. You could do like all sorts of looks with this same sphere. I'm just changing one single parameter here. Using one single shader. What else we could do? We could actually even make it like smoother than that. It's gonna be pow. Oh, this is weird. I think the one that I used before was the best one. Like this one, for example. What else? Do you have any idea what we could change here? I think I'm done for the animation I was planning to do. Right now it's just all about experiments. We could also try to do, I don't know how it will look like. So let's just go for it, the simplest lightning again. So we have the normals, and then we could do the something like that. Didn't quite make the difference. I'm just randomly multiplying and raising to the power right now. I like this dark side of the GIF. Also looks kind of beautiful from the inside too. I like it. Let's just make it a bit slower. Like say this. I think this is another GIF. We just created another GIF, you know. Just another beautiful art. Maybe we could do something different with the particles. I could move them inside. Yeah, why change this? Why create a variable if you could just subtract things? Yes, now the particles kind of inside, maybe even. Well, it's weird, but I happen to like it. What do you think, guys? Yeah, let's extrude the points a bit. This one we just need to create something like this. That's too small. Yeah, this is also beautiful, isn't it? Well, you could do anything with this one, and I think you should. It's not just you're able to do this. It wasn't that complicated. You should try to do this, and when you see this thing on your screen, I bet you would be happy as I am. Yeah. I also created another demo with the React3 fiber, and just as a bonus content, everybody who's still with me, I can show you something. Yeah, I also love the darker color, yeah. You can try experiment yourself. You see, it's just one geometry, one vertex shader, and infinite possibilities. So I'm gonna post this thing pretty soon too, but just check out what is possible with this threejs in the browser right now. Just check this out. This is also done with React. Come on. How the fuck would I drag this one? What is wrong with you guys? I just can't drag this thing out of there. Maybe do they have some preview or something like that? Current model view, like a full screen, open a new window. Yeah, like that. Whew. Yeah. Yeah, of course I can make them round. Just that I'll show you this demo and then make the points round. I think I even like this square look because this whole geometry is all edgy. But you might be right, it would be a contrast with the edgy geometry, the round point. What the hell is transpiling all the modules? Now we have the infinite loop. Okay, I'll show you this demo later on then. Sandbox keeps breaking for me. Let's make the points round, like how the David suggested. And to do that, I will use the fragment shader. I wonder if that will break the line geometry, but let's just try that. So we have the GL point cohort usually here, so I can just try. Yeah, now we see the cohort. Now we can do the I'm just doing round dots real fast. Now we have that, and then now that's circular. Whoa, this is a whole new look. It actually changed the feeling of the animation. I like that. Oh, that was a real cool suggestion. Yeah. And it looks beautiful from the inside too. I kind of like this one. I know it's just looking from the inside of the sphere, but I just like how it looks. I think I could look at this forever. Alright, and see, it even has this vibe like it seems like sometimes the points being reflected on the sphere, but it's not true because we're just looking through the sphere and some points are under the sphere, and that's why we see them. But the illusion is big that you see the reflections of those points. It's like the surface, the water surface or something like that. So yeah, it's pretty beautiful. I think that was it. You could continue experiments yourself with that one. Thank you for supporting me today. Hope you liked that one. Because I did. I really did. I don't even know if I want to change the view of this stream right now because it looks so cool. Alright. Thank you guys for being with me today. Thank you for supporting me. Thank you for getting up so early or staying up late just to watch my stream, and thank you for watching my stream in the record anyway if you're looking. You can leave the comments with suggestions, with something you'd like me to do, anything, maybe some good words too. You can support me on Patreon, by the way. I have the Patreon. It's all your HTML Patreon thing, and I wish you a good day. Hope it's gonna be fun. Say some kind words to the people you love. Do some good shit. Do the animations and have a good life. See ya, guys.